Alright guys, in this video I'm going to show you guys how to do three different things. We're going to look at adding polynomials, we're going to look at subtracting polynomials, and then we're going to look at multiplying polynomials. So you may have done this in the past, but this might be a nice refresher for you, a nice breather to get through this section without too much complication. However, if you haven't seen it before, take some time with this and make sure that you understand it. There's a couple different ways that you can add. You can do it horizontally, or you can do it vertically. I always just do it one way. I always just do it horizontally, but if you like to do it vertically, take a look at the textbook. The textbook shows you how to do that vertically, but I'm going to do it horizontally. So in the example here, you can see down here where it says you're going to add 9y cubed plus 3y squared minus 2y plus 1, and we're going to add it, and you're going to basically add it to negative 5y squared plus y minus 4. And we're going to use the horizontal format, but again, in this section, it does not matter to me. Ask your teacher if it matters what format they want you to do it in. All I'm concerned with is you guys being able to add these two expressions together. So I wrote it down like this. So the first thing you can do is really you can just get rid of the parentheses. And the reason I put parentheses in there is because when we go to subtract, those parentheses are important, because if you think about it, what we're really doing is I'm adding each term to here. So when we do get to subtraction, I'll explain that in a little bit more in depth. All right, so what we have to do is we have to figure out, do we have any like terms for y cubed? Do I have any y cubes over here? No, I don't. So all we have to do is write that down. Easy peasy, right? So that guy's done. Then the next one, I look for like terms and I go, okay, this is a like term of this. This would be a like term of this. And I don't know, we could do a little heart. Valentine's Day is coming up. That's a pretty bad heart. But you can see what I did is I just used shapes that align the like terms together. You can use different colors if you like using color-coded things. You have different pencils, pens, or whatever it might be. So now from here, 3 minus 5 is negative 2, and all we do is keep the variable along with it. And then negative 2 plus 1, right? So that's going to be negative y, or negative 1y, but we don't have to put the 1 if we don't want to. And then the hearts, 1 minus 4 is negative 3. So that right there would be your final answer, right? So that's all we're doing. Don't make this more complicated than it has to be. I think the complication comes in when we subtract this one little piece that we might forget, and I'm going to show you that right now. All right, so you can see the next example that we're going to look at is I'm going to be using subtraction. Now, look at what I wrote here compared to the example down here. Now, the example down here, it says subtract 3z squared plus z minus 4 from 2z squared plus 3z. So make sure you understand how to set that up. We're really taking this quantity and subtracting it away from this quantity. And when I do that, whatever I'm basically subtracting from the other quantity, I put it in parentheses. And this is what I meant when we were adding. This is the important piece. I cannot get rid of these parentheses right now because of the fact we're subtracting every single term. If you just remove the parentheses, all that would state is that you're subtracting the 3z squared. We're not really doing that. So what I usually do, and always helpful for me, is I usually put a negative 1 in here, right? And that reminds me that, okay, if I do that, I know that now I have to distribute, and really what I'm doing is changing this problem really into an addition problem. Because remember, the subtraction rule means that you add the opposite, but here really we don't really have to worry about that. As long as we distribute, this will change, this will change, and this will change. So now if you look at this, you go, okay, that's very similar to what we just did on the first example, right? So now from here, we're going to look for like terms. I'm going to use some circles. These guys are like terms. Use a square, and it looks like the 4 doesn't have any friends, but he'll be all right. All right, so 2 minus 3 is negative, so negative z squared. And we always want to put these in order too. I didn't state that with example 1, but make sure we put them in standard form, highest degree to lowest degree. And then the squares, so 3 minus 1, right, because this is really a 1 in here. We just don't put it, so that would be plus 2z. So basically did this. I should cross them off so you don't get confused, especially if there's a lot more of them. And then the 4 comes down. And that's it. So when I subtract 3z squared plus z minus 4 from 2z squared plus 3z, that would be your final answer. Big takeaway here is note this somewhere, is distribute that negative, or distribute that negative 1, because if you don't do that, you're always going to get the wrong answer. I know someone out there is going to do it. Don't be that one person that will do that, okay? And all right, so when you multiply, you can use the vertical format, you can use the horizontal format, but what I'm going to show you is the box method. And the reason I do the box method is because when I show you guys how to factor, that's how I do that. So we're really multiplying this quantity by this quantity, so it's really going to be a 3 by 2 box. So all we're doing is making a 3 because 3 terms, boom, and then 2 terms. Okay, so that's all we have to do. So the 3, and you could do it vertically too if you wanted to. You don't have to do it this way. Really, you could change your box and change the direction of it. Totally up to you. Now when you have it set up that way, the reason I like it this way is because the fact it stays organized for me. So what I'm going to do is basically we're going to find the area of each box, right? This times this would be negative x cubed. This times this would be 2x squared. This times this would be 4x. This times this would be 3x squared. This times this would be negative 6x. And then this times this would be negative 12. So now when you put this on paper, super organized, and we can look at it and go, I may have got the wrong answer, but then we can look back and go, okay, well, maybe you screwed up here and there, wherever it might be. Now, the other cool thing that I like about this is it keeps, if you look on the diagonal, do you notice that the like terms are matched up? So if you notice like term, and then like term, that's always going to happen. So that's why I like this. All right, so now we're going to put it in standard form. So it's going to be negative 3x plus 5x squared. All I'm doing is combining my like terms there. And then I'm going to combine these and get negative 2x minus 12. So that is your final answer using the box method. I know the book asks you to use the vertical or horizontal format. To me, totally up to you on how you want to do that. You could use those two methods if you want to, but in the practice, I would suggest using this method. But if you want to use also other ways of doing it, you can do basically this method right here, which might be totally confusing to you guys. So, right, that's just like the FOIL method or distribution method. However, not a big fan of that because that gets so confusing for me. It's like too many lines. I can't follow those lines. What's going on? And it kind of gets confusing for me. And I don't even know if hopefully I set that up the correct way. But that's how I always use the box method. So it works for me. Hopefully it works for you. All right, guys. So this is the last example. And what we're going to do is we're going to multiply x minus 5 times x plus 4 and x plus 5. So what you have to do first is we're just going to focus on this as this multiplication problem right here. Now what you can do is you can FOIL that, or you can use the box method. As you know, I always use the box method. So x minus 1, x plus 4, x squared minus x, 4x minus 4. Always line up nice and neat. So when I put this together, you get 3x minus 4, right? So now, since I multiplied x plus 4 and x minus 1, and I got the product x squared plus 3x minus 4, that means I have to multiply this guy to this guy. So I'm going to do a 3 by 2. And then once you have that set up, now we're going to multiply those out. Again, you don't have to use the box method. I just prefer it because it keeps you nice and organized. All right, so I sped up the video there, so make sure that you pause it and take a look at it. Make sure you understand what I did there. Very similar to the previous multiplication problem. However, when you do these, we have to focus on this part first. Once we get the product, which is this guy right here, x squared plus 3x minus 4, we take that and multiply it to the other one. You could also multiply these two first and then take the product and multiply it by that. However, if I didn't make any mistakes there, that is how you would get the correct answer. So really take your time with this, slow down, and you guys should be golden. All right, so have a good day. So guys, here you'll see that some binomial products occur so frequently that it's worth memorizing some of these patterns. I'm not really going to go over some examples on this. They are in the book, so if you want to take a look, and we have in the past gone over some of these, but I would take a look, jot them down if you think they might be useful for you. I think they will, and it'll save you some time, like sum of difference patterns, square of a binomial. We've done all of those. The only thing that you haven't seen yet is a cube of a binomial, and we might get into that a little bit later on. But take a look at it, look at those examples there, and see if it makes sense to you. But overall, it's something that will be helpful because it's going to make you more efficient down the line. All right, have a good day. I'll see you guys in class.